Hello and welcome. So this time around, I wanted to prepare for my GOAP implementation in Rust the actions I had in my original JavaScript implementation. Of course, I've created the basic action struct in code already. I called it a GAction, and I just tested if it would update the state. If you've seen it in a previous session, let's maybe demonstrate slightly. Cargo run. So here we wanted to write has ammo to true after the G action would kind of continue its work, and has ammo, yeah, it was set to true, so that's fine. So we tested one implementation, like one instance of GAction with its functionality, which is still overkill in here. I looked at the code and pretty much noticed that this entire GAction could be just a struct with a bunch of hash maps associated, and all that stuff would be just simple functions. I mean, it is working with basic. We are working with basic hash maps here. So, long story short, I will move it to general functions. So this is moved already. I just associated another method to work with it correctly and access internal states, whatever. But yeah, and this could also be nice to merge several hash maps together to get like what we want. But this is only one instance of GAction, like this part, right? So the object inside the specific key. But as you see, I need to have a giant object of varying key for a name and a specific object structure inside, and these are hash maps that we created previously. So yeah, so one of the most popular ways apparently is using JSON Serde, Serde, big D in German. And apparently I can have a struct and data, and after I deserialize from string, I will have my object ready. So this is fine, but I wanted to test it first before I start implementing that. And the nice thing about the playground is we can test Serde inside it. I actually tried some other example before, but I think for now I'll just grab this maybe because it's ready for us to use. So bam, whatever that stuff does, and I actually copied the very first thing from the doc. So yeah, I don't think I should actually create a let. Let me check if it works first. It should potentially eat up. Yeah, it actually did compile. Please call John Doe. Please call something, name and phone number. So this thing was possible to be read. So what I need to check is I need to check if my object can be translated to that. And so in our example, we don't have anything complicated actually. We have a plain hash map of whatever key and a boolean. So this would be false, and this would be true. Um, and this already is not needed. Yeah, let's keep it there. And this was what was the syntax? Hash map. So hash map string boolean hash map of string bool. So technically this should be able to get something by the name name. So I'm gonna see if this is going to be a sum true, and if it works, then I will probably set up a I'll probably set up Serde for my project, and then in the next session I would kind of replace all the enums I had, and I would work import data from files. I will actually write reading JSON from file. So hash map not found. Oh, I didn't import it. How was I supposed to import use std collections hash map? So sometimes I figure Vim and like Emacs with Vim bindings is too complicated, but I'm trying to become faster at typing, and you've probably seen that. Oh yeah, so this is an option, and we don't specifically say how this option is supposed to be displayed, and we're just gonna rely on standard formatting. Please call. Did it run? Hash map. It read something. From string data. Doesn't work. It didn't fail, right? Unused result, it must be used. Oh, Jesus. Maybe I should rerun it again, and it maybe just didn't understand. Please call. There's no please call here. P get name. Why? Why is it like this? Why is it like this? So it read data. It did something. Wait, let me just return it as it is. It's not used. Typed example. How come is it saying that we're not using the function? It should be handled. Do we actually care? It's not an error. See, this is a problem. I don't know what it does underneath. Okay, I'm gonna output something, and this is going to be the P thing, and this is going to try and give us the bool. This is what this is going to be returning, and this will just give us the result. Trailing comma line 5. The hell is this? Column 9. Oh crap. Is this the error? I hate you, Rust. I hate you so much. So it did work. It did work. So now I know for sure that I need to use Serde. I know how to use it. How do I install a package? Rust Rust install create. Uh, so see in action, getting help. Where is installation instruction? I forget everything. So it's in MIT, which is nice. How the hell were we supposed to install packages? I haven't opened Rust in quite a while, and I freaking... Yeah. So it's copied. Oh, okay. This was not informative. So cargo toml and bam. So in this entire project, I believe this will be the only external package I'm going to use, because I'm beginning to really need a way to load a JSON, and in the future maybe I do want to build a small service to accept a JSON structure and spit out as a result based on whatever world we have. Okay, so as soon as it's done, I am going to stop. Although, you know what? Let's stop here. This is short stuff. So we experimented with Playground. Playground is great. You don't need to wait for huge installation times. So this was crap. We don't need it. Um, yeah, we just such a simple error. It was a very simple error. Your data. So we don't even need this anymore here, right? And don't need this. Yeah. All right. So it's there. All right. So I really liked the session. Um, I learned something. Uh, I tried Serde like half a year before I attempted to do GOAP algorithm. Yep. Now I'll be able to build a JSON and like a proper JSON on a file system next to um, these sources, and I'll just continue with that I had before in simple JSON format. So this entire thing will be JSON format. The goal will be a simple JSON format. This will be a general function, and this will be simple JSON file. And we'll continue with implementing, like doing actual implementation of pretty much one function. This entire thing works with just one recursive function. Alright, I hope I didn't bore you way too much. And just to show off, so most of the time it works with within 200 microseconds, and in release, actually, I'm not gonna show it. It's gonna compile. Although no, wait, I will show it. So it again, it kind of halved the entire, not even halved. It's considerably faster. So cool. Another empty episode, but I learned something, remembered something.